Okay, hello guys. I'm going to go ahead and walk us through how each question should have been answered, or the thought process behind it for our first test. This one is the original version, not the version 2. If you had the one with the 2 in parentheses behind it like that, you'll want to go and find the other movie. These had similar questions, of course, but it'd be different numbers. Okay, go ahead and if I can figure out how to zoom in, maybe. There we go. Our job was to find the answer and write the answer in simplest form. Anytime I'm adding fractions, what you want to think about is this bottom number represents a unit. Like centimeters or inches are a unit. So if we had 5 inches plus 17 feet, we wouldn't be able to add those together very nicely. And so what we learned with that, it translates over to the same kind of thing as if this is 5 and our unit is sixths, that's messy, and we're adding to that 17 halves. Okay, sixths and halves are not the same unit, so we've got to do a conversion of units. When we're converting units, we don't want to change the overall value. So that's when we look at our fractions and we say, okay, well, this has 6 in the bottom, and the one on the right has, that one has 6 on the bottom, and the one on the right has 2 on the bottom. And so that's where we'd have to find our least common denominator. Okay, which is also known as the least common multiple for the bottom two, or the smallest number that both of these can multiply into, which would be, in fact, 6. So since our 5 already has a 6 on it, we'll go ahead and get a different color here. Leave that one, but the 2 is going to have to change. So we'd say, okay, well, 2 times what equals 6, and that's 3. Now, if I were to just leave it like this, that would be as if I had gone like this and said 17 halves times 1/3. Right? The 3's on the bottom. We automatically know there would be a 1 on the top. The problem is that multiplying something by 1/3 is taking 1/3 of its amount. So it's going to change the overall value. So instead of multiplying it by 1/3, again, we're changing the unit, we're not changing the value. We'd have to put something on the top that would essentially make what we're multiplying by here have a value of 1 overall, and that's this, 3, because 3 divided by 3 equals 1. It's a really ugly one. Okay, and so that is not going to change our value. So what we get when we do that, let me erase some of this, and I'm sorry if it's a little ugly here, first time using this app. Okay, what we would end up getting is if we multiplied it by the fraction 3/3, which has a value of 1, so I'm not changing how much 17 halves is, what I would get then is 17 times 3, and let me get my calculator here, which is 51, and 2 times 3, which is 6. Okay, now that we have the same unit, it's 5 sixths plus 51 sixths is going to equal how many sixths? Because that sixths is our unit. Just like if you had 5 centimeters plus 51 centimeters, the answer would be 56 centimeters. Well, the answer in this one is 56 sixths. Okay, that takes us to our next problem over here. We're going to follow the same process, only we have sevenths and ninths. Again, two different units, so we want to convert one or both of them so that they are the same. Least common multiple for 7 and 9, if you remember doing this by hand, you just start multiplying. 7 times 2 is 14, times 3 is 21, times 4 is 28, times 5 is 35, 42, 49, 56, 63, 70, and then you'd take the 9, 18, 27, 36, 45, 50, did I count wrong? No, 54, 63, and the moment you have a match, that's the very first match you get is your least common multiple. That's stuff back from elementary school, but I'll remind us. Oops, not 6. My undo button isn't working. Okay. Now I need to get the least common multiple. Well, 7 would have to be multiplied by 9, but we don't want to multiply by 1/9. We want to multiply by a factor of 1 overall. Well, 9 divided by 9 is 1. So we're not changing the value of, or the size of that 2/7 really. Putting in other units, which is 18/63. 8 times 7 is 56 over 63. Now some of you got stuck here and got back into like what we saw in elementary school, and you said, oh, no matter what, the bigger number minus the smaller one is how it goes. No, we learned that you can have negatives. So going from left to right, we get 18 minus 56 is negative 38. And then just like with the addition one, the 63rds is just our unit. Like if you had 18 inches minus 56 inches would be negative 38 inches. The unit hasn't changed. So there's our final answer on that one. Okay, coming over to 3. Now there are quite a few people who are fine on the addition and subtraction, but when it came to multiplication and division, you got stuck. May I suggest to you, if you can't remember which one is which, well, I don't know if I want to suggest it right now, but I'll say it and then you can choose to ignore it or not. But multiplication and division are the same thing. So what you can do is just, and listen to this, it's only the same if you have this understanding. Division is just multiplication by an inverse. What I mean by that, isn't 12 divided by 4 going to give us the same answer as 12 times 1/4? That says a fourth of 12. What's a fourth of 12? It's 3. 12 divided into 4 equal groups is also 3. That works every time. This is the whole idea behind the keep, change, flip. We keep the 12, change that to a multiply, the division to multiply, and then flip the second fraction. Well, if it's a whole number, whole numbers are all over 1. When we flip it, we'd have a fourth. Okay, so once we have that, then we just multiply straight across. So let me go down here to this guy here, and we'll change colors just to excite it up. Anytime you're multiplying fractions, we always go straight across. So we'd have 2 times 8, which is 16. 7 times 9 is 63. Okay, well, I'm going to check the factors. 16 I know can be broken down into, let's do it down here. 4 times 4, which is 2, 2, 2, 2. 63 can go to 7 and 9, 3 and 3, so we really just have 7 times 3 times 3. Can't simplify that any further. They don't have any common factors down here. So that's it. Now, what was I saying on the last one? Don't be worried about the division, just treat it like a multiplication. And remember that division is just multiplying by an inverse. So that might be a good thing to write down and get memorized. Put it above your toilet or something so you see it all the time. Equals multiplication by inverse. Now, how do you know which one to inverse? Well, remember it this way, reading from left to right. Multiplication by inverse. The inverse comes second. Okay, so what that would mean on this one is we'd keep the first one, multiply the inverse of the second one, so 2/15 is the inverse. Reciprocal, I guess. You know what, I'm going to change that and say reciprocal. I'm trying to think of when technically those are not the same, and that comes with our trig functions. So I should not have said inverse. Reciprocal is the important one. I'm sorry if you wrote that like I asked you to, and then I had to erase it. Okay, multiplying by the reciprocal. Okay, well now it's back to the same problem we had last time, multiplication. 5 times 2, multiply straight across is 10. 6 times 15. Well, here's a trick for doing big numbers in your head. Break whatever big one is into factors, and you can just distribute, right? 15 is, excuse me, not factors, addition. 15 is 10 plus 5. 6 times 10 is 60. 6 times 5 is 30. 60 plus 30 is 90. Okay, well because I see those both have zeros in them, I automatically know 10 is a factor. So if I divide the top by 10, I get 1. Divide the bottom by 10, I get 9 and 1/9. I know can't simplify any further because 1 can't simplify any further. Let's go to our equations over here, algebra. Key on these is to get x alone. So when I get to question 5, x or c, I want to get c alone. I gotta kick someone off the island first. Survivor kind of thing. The c wants to be the winner, so we're gonna get rid of the people furthest from it by doing the inverse operation. So I'd have c over 5 equals 5. Cool. Now some of you instantly see that and go 1. Okay, well look at what the question is asking. What number, that's what your variable represents. We're just too lazy to write that question over and over in the same spots. Okay, in the place of c. What number divided by 5 equals 5? Well, 1 divided by 5 doesn't equal 5. 1 divided by 5 equals 0.2. What number divided by 5 equals 5? Well, that's 25. Now, seeing that algebraically, we have learned that the inverse operation of division is multiplication. And what I do to one side, I have to do the other to preserve equality. And I'm sorry that that's not up higher. It should be 5 over 1. That 5 is in the top, so that 5 over 5 gives us a factor of 1. And 1 times c is c. 5 times 5 over here is 25. Okay, question 6. Tricky one here is those parentheses. Freak people out. Parentheses, when it comes to like addition and subtraction, don't really make a difference. You'd see it when there's a double negative, just to remind us. Oh, put a plus sign. Minus a negative equals plus, so if I rewrite this, I have 8 over u plus 2 equals 6. Okay, you got to kick someone off the island. It's going to be the person further from the u. When I subtract that, I get 8 over u equals 4, because that is a 6, not a b. Okay, now again, I got a lot of answers of 2. No, what answers did I get? 1/2, right? Because people are like, oh, there's an 8 and a variable, and I'll just divide out the 8. Well, no, you can't divide out the 8 and be done. Yes, you can divide out the 8 and get u almost alone, and that would be dividing out an 8 would be the same as multiplying by 1/8. We'd have 8 over u and an 8. Well, 8 divided by 8 is 1. Gotta move this up a bit. And so we'd have 1 over u left over. On this side we had 4/8, which is also known as 1/2. Okay, but the problem didn't tell me to find 1 over u, it asked me to find u. Okay, well, a little trick here. Anytime you have two fractions and an equal sign in the middle, it's a proportion. So if you cross multiply, 2 times 1 is 2, u times 1 is u, and there is our answer. Now, do you really need to go through all that? No. If you're paying attention and putting words to what the question is saying, back up here I'm going to rewrite it. 8 over u equals 4. Ask yourself what the question is asking for. What this is saying is 8 divided by what number? That's what that variable is representing, a missing number. 8 divided by what number equals 4? Well, 8 divided by 2 equals 4. Guess what? Same answer there. This just showed it algebraically down here. Okay, last but not least, we have the system of equations. I'm just going to show you the quickest way to solve this. Your options were substitution, elimination, or what's the last one? I can't think of it right now. Oh well, must not be meant to be. I'm going to go ahead and do, I see C alone, so I could do substitution pretty easily. I know a lot of you like elimination though, so let's just do that, elimination. Okay, the one I'm going to get matching, we need a variable matching. I'll go ahead and match the C's. In order to do that, I'm going to need to multiply everything up here on the top by 5, which would give me negative 25A plus 5C equals negative 150. Okay, so that equation I'm not going to worry about. Now the hard part here is, do you multiply or do you subtract? Excuse me, add or subtract? Well, test it. If I were to add my matching variables, or if I were to subtract my matching variables, which one would get me a 0? Well, minus a negative makes a plus. That would give me 10C. That's not 0. Positive plus a negative is 0. So it looks like addition is going to be what we'll eliminate. So negative 25A plus 4A, because that wasn't there, that was just our question, is negative 21A. Negative 5C plus 5C is 0, so I'm not going to write anything. Negative 150 plus 24 is negative 121. Well now, quick solving, we would have A equal to negative 121 divided by 21. Why is that not right? Oh, because it's not 121, 126. Sorry, it's late. Okay, negative 126 divided by 21. There we go, negative 6. So, oh, nope, we divided by negative 21, so that's going to be positive 6. Cool. Now, last step, I got to plug it back in to find out what C equaled. So I'm going to use my original one because I see that C is almost all the way alone. And I would have negative 5 times the A value, which is 6, plus C equals negative 30. Well, that gives me negative 30 plus C equals negative 30. Now, if you're not sure what to do here, because, wait, what happens? How do I get rid of that negative 30? Well, look at the question. What does it say? Negative 30 plus what number equals negative 30? What's the only number you can add that won't change the value of something? 0. Algebraically speaking, we could show that. The opposite of a negative 30 would be to add 30. And we would have 0 as well. Okay, continuing on to the next one. Oh. Okay, slide 2, we're getting into our radical expressions. I'm going to go ahead and zoom in here. Whoa, I didn't know it could twist like that. Cool. Okay, Writing them in simplest exact form, this is where we are looking for the couples to go out on the dates. And I don't have these memorized. I see that 6, and I know if it ends in a 6, it's got to be, well, if it's even, it's got to have a factor of 2. So I'll go 216 divided by 2. It goes 2 and 108. Okay. Don't forget my square root, so I remember what things are in and out. 108, I know, is another 2. Bring that other 2 down. That's going to be 54. Okay, now it's starting to look familiar. We'll put the next one. We have the first 2 and the second 2. 54 can be 6 and 9. And then if it's all right with you guys, I'll just finish 2, 2. 6 goes to 3 and 2. 9 goes to 3 and 3. And now pulling my couples out, we have a pair of 2's that come out and a pair of 3's that come out. So on the outside we have, and they come out as a single couple, so we have 2 times 3 on the outside. And on the inside we have 3 times 2, or in other words, 6 root 6 is our final answer here. On the next one, got that 2 outside, but we'll start breaking this down. 125, I know because it ends in a 5 from my elementary school tricks that 5 is a factor. And if we take 125 and divide it by 5, we get 25. Okay, the next 5 comes down because that can't break down. 25 becomes 5 times 5. And we're ready to pull dates out because those are all prime now. And I'll pull out a single pair, a single couple, and we have a 2 on the outside, and now a 5 on the outside with 1 5 left inside, so 10 root 5 is our final answer. Number 10. We have the 8 on the outside and we have the k's. So let's put that -8. 24 I know can go to 6 times 4. K is going to go to K, 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 with 3 K's there. We have the -8. 6 goes to 2 times 3. 4 goes to 2 times 2. And then we still have the 3 K's. And now we're ready to pull out our our couples. Got a couple of 2's and a couple of K's. So we have a -8 out here. Single couple of 2's, a single couple of k's, oops, not equals, and then on the inside 2 times 3 times k. So our final answer becomes -16 k root 6k. Okay, number 11. This one we've got some distribution going on because we know order of operations when we simplify this says start on the inside first. We can't add things that don't have the same number under the radical, so I know that I can't put those together, not to mention that this one doesn't even have a radical. So we'll have to distribute. So distributing our 2 root 5, that single term, into both of these, we would have 2 root 5 times root 6. And we copy our same sign, plus 2 root 5 times 2. Now using our rules, outside with outside, inside within, 2 root 5 times 6, well 2 times the coefficient of the other one right here is a 1, is 2. 2 times 1 is 2. Root 5 times root 6, those are both prime. Well, 6 isn't prime, it goes to 3 and 2. I know there wouldn't be any couples, so I'll go ahead and put the root 30. And then copy the plus sign. 2 root 5 times 2, that's going to be 4 root 5. Okay, now most common answer I had here was some version of like 6 root 35, where you like added the coefficients and added things under the radicals, or some people multiplied the coefficients and then added the radicals, both of which are wrong. The whole reason we distributed up here was because the inside we couldn't add because you can't add them unless they have the same number under the radical. 30 doesn't have the same number under the radical as 5 does. And we can't simplify 30 any further to make it possibly equal a 5 by pulling couples out. So that's as far as you can go. Oh. Well, I don't know where that went to. Trying new stuff here. That's weird. Okay, 12. At first glance, we see a root 24 and a root 6. We'd say, oh, those can't get subtracted. But double checking that, we do know that root 24 does simplify to 4 times 6. And 4 becomes 2 times 2. 6 becomes 2 times 3. Well, a single couple comes out here. We'd have 2 root 6 minus 5 root 6. Holy cow, they're the same now. That's like if you had 2x minus 5x. What would that equal? Well, negative 3x. Guess what this equals? Negative 3 root 6. Last of the radicals, we have root 20. 3 root 20 over 2 root 4. My suggestion to you to save you time was always to simplify outside with outside and inside with inside as much as possible before doing rationalizing. Outside with outside, 3/2 can't simplify, so that's going to stay. Inside with inside, well, 20 over 4 simplifies to just a regular root 5 in the bottom right. We can divide out by root 4, divide out root 4. This right here would equal 1, and 1 times 2 is 2. On the top we have 3 root 5, so making it writing a little nicer. Still can't simplify the 3 and the 2. We don't have any square roots in the bottom, so that's what we've got. Okay, our special angles, a lot of you forgot the names of these. Let me just write those over here. We have corresponding, alternate interior, alternate exterior, consecutive interior, or this one was also known as same side interior. We also had vertical angles. And the last one we had was linear pair. Okay, well in question 4 we have angle 4 and angle 5. Those are both within the parallel line, so they're going to have to be one of our two interiors. Well, they're not alternating sides of our transversal, so that must mean that they are consecutive interior or same side interior. And we learned that that had a relationship of being supplementary. What does supplementary mean? Two angles that add up to equal 180. Okay, we'll put in for words what you've got. Two angles, angle 4 and angle 5, and they add together to equal 180. Well, that means our equation would be 5x squared plus 110 equals 180. I didn't leave much room on this, sorry. When I subtract 110 from both sides, I get 5x squared equals 70. When I divide 5 out of both sides, I get x squared equals 16. And when I take a square root of both sides, I get x equals positive or negative 4. I took if you just put 4 down because we haven't been worrying about the positive or negative. Okay. On the next one, we have angle 6 and angle 2. They're not both inside or both outside the parallel lines, so that gets rid of interiors, exteriors. They're not like on the V vertical angles where two angles across from each other, so it's not that. Together they're not making a line, which is linear pair, two angles that make a line, so it's not that, which means they have to be corresponding. Oh yeah, corresponding meant they were in the same corners of two intersections. These are both in the bottom left-hand corners. Of the intersections. Okay, our relationship was that they were congruent, and it even looks that way in the picture, which is always nice. Congruent, so angle 6 is congruent to angle 2. We know congruent means the same as, or in other words, equal. Angle 6 is 4/3. Angle 2 is 3x squared. And to solve that, we would have to divide by 3. Okay, we know dividing by 3 is the same thing as taking a third of something. Of means times, so multiplying by its reciprocal. 4/3 times 1/3. Keep, change, flip is the other way to refer to that. Equals x squared, because that equals 1. That gives us 4/9 equals x squared. To get rid of that, we take the square root. X is equal to the square root of 4 over the square root of 9. You can split up square roots like that on fractions. And that ends up being 2/3. Sorry, my work got kind of sloppy in there. Okay, special right triangles. I'm going to move in here. We had our basic rules. We'll put those over here first. If you have a 45, 45, 90, the two sides and the two smaller angles are congruent. There's our right angle. These sides are x. To get from the legs to the hypotenuse, we multiply by root 2. To go the other way, we divide. Our other triangle was the 30, 60, 90. 30 was across from the short leg. 60 was across from the long leg. 90 is across from the hypotenuse. We always found the short leg first. Doubling that gave us the hypotenuse. Cutting hypotenuse in half gave us the short leg. Multiplying the short leg by root 3 gave us the long leg, and then dividing by root 3 took us from long leg to short leg. That's the rules we're using here. Sure, you can use SOHCAHTOA, but it wouldn't give you, Trig, but it wouldn't give you an exact answer, because anytime we push the trig functions, it doesn't give you the exact answer. Provided that it's not one of our, my eraser doesn't want to work. Okay. Provided that it's not one of our doubling ones, like 12 to 24 on number 18. So on this one, our first question is, what kind is it? Oh, it's a 45, 45, 90. What do I have? I have hypotenuse. I'm going to leg. 45, 45, 90 has the root 2. I'm going bigger to smaller, which means most likely I'm going to be dividing by root 2, which is correct. Now, those one's inside, one's out, so I can't simplify it that way, but I know I can't leave that root 2 in the bottom. Multiply by a factor of 1. That will get rid of the root in the bottom. And it's not changing the overall value, and I would get 8 root 2 over 2. Ah, bad news. 8 and 2 that are both outside now can simplify. 8 divided by 2 is 4. So 4 root 2 is the final answer. Okay, on number 17, we have the leg, and we're going to hypotenuse on the 45, 45, 90. That means multiply by root 2. So we have root 5 times root 2. Those are both inside, so we can multiply them. If they were being added, we wouldn't be able to go any further, but multiplication you can, so we get root 10. 18, 30, 60, 90. This is the short leg because it's across from a 30 degrees. We're trying to find the hypotenuse because it's across from the 90. So there's the 30, there's the 90. And we know our rule says take the short leg and multiply by 2. So the hypotenuse is 24. because that's a whole number one. Even if you did trig, that would come out the same. Yeah, we'd have that exact answer. It's our square root, so it wouldn't come out exact. 19, we have the long leg because it's across from the 60. We're going to the short leg, which means I take my 12 and I divide it by root 3. Same as up here in number 16. Can't simplify it this way, but I do know I can't leave that root 3 in the bottom. So I multiply by a factor of 1, so it doesn't change the overall value, and the factor of 1 I choose makes it so that the bottom square root simplifies out, and it gives us a regular 3 on the bottom and 12 root 3 on the top. Now outside we have a 12 and a 3 that can simplify to 4 root 3. Whoops. Oh no, I moved it, but I don't know how to. Oh well. Okay, last but not least, 30, 60, 90, we have the hypotenuse. We want the long leg. We don't jump right from hypotenuse to long leg. We've got to jump to the short leg first. Well, hypotenuse to short leg, we divide by 2, so root 6 over 2. Can't simplify that any further because the root 6 is under the square root, 2 is not. 2 is not a square root in the bottom, so that's as far we can go. Then to get the long leg, we multiply by root 3. Now we're changing the value. We're not multiplying by the root 3 to simplify here. We're multiplying by root 3 because that's what the formula says. So notice I'm not putting root 3 on the bottom. I'm multiplying by the number, changing the value by a factor of root 3. Well, that would give me root 18 over 2. 18 is 9 times 2. 9 would come out as a 3 because 9 is 3 times 3. And so there's my final answer, 3 root 2 over 2. Okay, almost done. Last 3 questions were trig ones. For the most part we did, oh no. For the most part we did really well. Sorry, I pushed the wrong button there. But on these ones, we'll just remind ourselves here. 21, we have to choose our reference angle. We're looking for side C. We learned that in any triangle, angles are capital letters. Sides, if you're going to represent them geometrically, you can use either endpoint, so side BA, like that, or you can use the lowercase version of the side of the angle opposite. So this side could also be called little c. This side, little a, and that side, little b. 2 different ways of writing it. So side little c is the side opposite big angle C, or in other words, the hypotenuse here. Okay, well I'm going to choose the reference angle that's given to me. I already have hypotenuse. This over here would have to be the opposite, and 7 would have to be the adjacent. So based on what I've got, what I'm looking for, using SOHCAHTOA, I want the hypotenuse, so it's going to need to be one of those, not tangent. And I have the adjacent, which means cosine. So cosine of the angle, 56, is equal to adjacent over hypotenuse. Oh no, that variable's in the bottom. First thing we want to do, get it out of the denominator. Well, that means multiplying it by c over 1. What that's going to give me on this side is 7c over c. Well, c over c equals 1, and 7 times 1 equals 7. That's the background behind that. Here I'd have c times cosine 56. Now I need to divide out a cosine 56 from both sides. That is a single ugly number. And so c would equal 7 divided by cosine 56. 12.51. I didn't tell you what to round to. Let me make sure my calculator is in degree mode, so I don't tell you wrong. 12.51 is the answer. Double checking up here, does that make sense? Well, yeah, that's a hypotenuse. It's going to need to be bigger than 7. Okay, on the next one, same process. We'll choose B as our reference angle. This guy's going to have to be hypotenuse. We're looking for side little a. Well, that's going to be opposite angle big A. Well, nice thing with our reference angle being B, that's also our adjacent side, so that's convenient. And then over here would be our opposite. Using SOHCAHTOA on this one, we have the adjacent, we want the hypotenuse. Excuse me, we have the hypotenuse, we want the adjacent. So cosine is A and H. So our formula would be cosine of our reference angle equals adjacent, which is A, over hypotenuse, which is 16. Well, this one's not as bad. Multiplying both sides by 16, we would have 16 times cosine 23 equals A times 16 over 16. Well, guess what? That's a factor of 1, so that is just A. And 16 times cosine 23 gives us 14.728. Just round to the tenths. Oh, wait, I think I did tell you what to round to. Yes, round to the nearest tenth. Oops. So 12.5 would be where we'd stop on that one. And then 14.7. Solve the triangle. So I put that hint. Remember what that means. All angles and all sides. So these are the ones where we set up this nice little table and had measure of angle A, measure of angle B, measure of angle C, which looks like our 90 degrees, then little side A, little side B, little side C. Little side A is across from here, little side B is across from big B, little side C. So A is 10, B is 14. Okay. I'm going to go ahead and start off with Pythagorean theorem to get my third side. I can do that because I have two other sides. So C is the hypotenuse, which means that's going to have to be the one alone on the other side of the equation. Equal sign. 100 plus 196. So 296 equals C squared, rounding to the tenth. When I take the square root of 296, I get 17.2. Okay. Now going on to our angles. Pick an angle we want to solve for first. I'll go ahead and choose B. Okay, angle B. Labeling the sides relative to that to use the trig. This guy over here would be opposite. C is the hypotenuse. A is adjacent. I would suggest again using the information that was given just in case we messed up on accident here on C. So we want to use opposite and adjacent. That would be TOA, tangent of our angle equals opposite over adjacent. We learned if we want to get rid of just the trig function, not the trig function of a variable like cosine 23 on our last one, we just want to get rid of the tangent. We learned we had to do the inverse operation. And inverse operations cancel each other out. So type in the calculator, inverse of 14 divided by 10 gives us 54.5 for this angle. Okay, now if you want to do trig just to make sure you're okay on the other angle, that's fine. I trust myself though. So since I have two angles out of the three, yeah, 54.5. I thought I messed up. 35.5. Okay. Now some might be like, well, wait, I got the right numbers. They were just in the wrong spots. Well, how would you have gotten that? That means you didn't understand and you set this up wrong. The only way you could get the wrong number for angle B, actually not the only way to get the wrong number, the only way you get angle A's answer for angle B would be if you accidentally made 14 adjacent and looks like I moved it. That's weird. 14 adjacent and 10 opposite, and then did tangent angle B equals 10 over 14, which wouldn't be correct for angle B. That's correct for angle A. Okay, so if you put your opposite adjacent by hypotenuse in the wrong spots, you'll have messed up angles and side lengths. And that is it. So if you have any questions, feel free to let me know. That sums up what we did on our test.